I'm Ryan Martens, and I'm a senior software engineer at Google. I've been at Google now for 3 years, and I work out of the Waterloo office here in Canada, which is about an hour from here. And today I want to talk about the project that I started when I joined at Google. At the time, the project was in its really early stages, so I've had an opportunity to see it grow from an idea to a prototype, and now actually turning it into a product with growing adoption. I've spent the last few months directly working with a lot of customers and users as they go through onboarding, both with the various aspects of this product. And so it's been a great opportunity to kind of like see it from the technical foundations of this and the whole life cycle of getting to something and getting like real user feedback. So it seems like it's an appropriate time to reflect back on how we got here. And as part of like the overview, we're gonna follow up with some more details on the product and what it can do for you, how it's being used, and finally a little brief demo of what it is. So first off, I'm just gonna give a really quick overview of the project that we're going to talk about today. We'll give more details later in the presentation, but just kind of like high level, we're talking about Bazel and Remote Build Execution. So Bazel is a build tool. There are other build tools out there, and I'll talk a little bit more about that later, but really it's an open source version of a tool developed internally called Blaze, which is the tool that Google developed for building and testing at an enormous scale. It's been in development for over a decade at Google, although Bazel was open sourced back in 2015, so much more recently, but it's been used extensively across the company. And Google developed this and a suite of other tools that kind of all work together in order to accommodate usage just of an enormous repository hosting almost all of the code at Google. And this is billions of lines of code, and it's called a monorepo or monorepository. And this is not just used at Google, although Google is one of the strong proponents of this, but it's been gaining adoption across a lot of other companies as they've kind of seen a lot of the use cases and the benefits of it. But as I mentioned, it's billions of lines of code, and it's an enormous number of changes that are all being merged, both by humans who are developing, as well as robots that are automated systems that are making changes and doing things. And just because of the size of this tooling, like traditional tooling just broke down and couldn't scale. Remote Build Execution is a cloud service that works in conjunction with Bazel. And it's just really meant to bring performance of Bazel up to the next level, and that's just via caching, as well as having shared pools of workers. So the Bazel-Blaze relationship is a common code base, but RBE was a little bit different because it had different requirements. Google had the advantage of having like a common set of infrastructure for the whole production environment and developer workstations, and that's not something that all customers have. So the use cases and requirements for RBE were different, and that caused us to kind of like refocus and rethink things as we were formulating a solution. So the mission of our team was really quite simple, and it's just to transform the development experience for everyone with fast, managed build and test for any platform. And as I mentioned, our team operates out of the Waterloo office, although we work closely with teams in New York and Munich. It's predominantly where Bazel is developed, but it's been developed largely here in Canada. So we have an ambitious mission, but it's still very much a work in progress. So in this whole looking back retrospective approach, I wanted to take a look and think about it in the context of waste management. And in particular, I want to think about how waste management can be applied to product development. So we're all familiar with the 3 R's of waste management: reduce, reuse, and recycle. But really, the whole focus of this on waste management is efficiency. The whole aim is to extract the maximum practical benefits from a product and to generate the minimum amount of waste. So there's a strong analog between like physical waste management as well as product development, in particular for software projects. So I want to apply these principles back to what we learned in developing RBE. So apologies to Steve on any comments I make about moonshots from the earlier presentation. But yeah, so first pillar is reduce. And then really in this case, the whole focus is on scope, or just trimming down scope as much as possible. And this is why the concept of an MVP is really kind of taken off and done really well, because it's all about thinking through what is the minimum set of functionality that actually solves a real problem, and nothing more. And just trimming it down to that and staying focused on that, and then iterating from there. But as we saw a couple slides ago, our vision is definitely much broader than anything that, it's definitely the opposite of reduce. It's very, very open-ended and broad thinking. So how do we kind of reconcile these conflicting objectives and allow them to work together? So I just think it's worth taking a step back and thinking about moonshots, especially because tomorrow is the 50th anniversary of the real moonshot with the Apollo landing. And Google X in particular is known for popularizing moonshots or 10X or just thinking differently, and it's even branded the Moonshot Factory. But really, I'd like to think about roof shots instead. They're less talked about, but they're a lot more common in practice, and I think a lot of moonshots are actually roof shots. So roof shots, the focus is on continual incremental deliveries, where you're kind of focused maybe on a moonshot, but you're thinking of the incremental path to get there. And in that incremental path, you're delivering continual successive improvements of maybe like 1.3x, 1.5x, or 2x, but you're doing it again and again and again, and in shorter periods of time. And when you do that, you eventually hit your 10x goal, but you do it with interim milestones along the way. And all of this can happen with lower risk, and it can happen with short-term benefits. You can get feedback from customers, you can actually put things in front of people, and it is just a much more incremental path to getting to kind of like the same outcome. And one method of thinking about this is a whole roof shot is you're always continually sighting the moon, but your actual sprints or developments or whatever it is that you want to focus on are just jumping to the next roof along that path. And it might not be the most direct path, but you kind of have your end objective in sight. And from an RBE perspective, we were really surprised what gaps users were willing to live with as long as it fulfilled a problem. Our first customer internally at Google as we were developing this was TensorFlow. And at the beginning, it didn't even meet all of their requirements, but it met some of them, and it worked well for some of them, and it allowed us to really kind of like make sure that we understood the problem that we were solving and the scope that we were taking on. The next pillar is reuse, and for this one, the objective is really to get to a workable prototype with the minimal amount of effort. And again, tying it back to the customer, you're getting customer feedback as fast as possible in order to evaluate any hypotheses that you have with your product. So you can figure out what works, what doesn't work, what needs more work, and maybe prioritization of different things. And another example of kind of like, just time to prototype is the monorepo at Google. Like the whole principle of a monorepo is just to make everything easy to use, readily available, and shared. So the monorepo just gave, it was enormous scale, but there were enormous benefits. So code reuse is the one key benefit of having a monorepo, and that's the one that's immediately obvious. But aside from that, you get improved dependency management, because you have a single source of truth. Everything's kind of vendored in or checked in. So there's no versioning, there's no daemon dependency problems. Everything is what you see in the repository. You don't have to worry about, versions between things and breakages and other things. Additionally, another benefit is atomic commits, because you can have a single commit that can actually touch huge numbers of files that span your entire repository, and you won't break your builds and tests. So you can make these sort of large-scale changes and not suffer breakages from them. And finally, you get improved collaboration. Users can see how a package might be used by other teams, or you can have contributors of a library that maybe you share that might add new features or pay down tech debt. So there's lots of advantages to this. But really, they're all about making it easier to reuse what other people have already developed and already maintain at scale. So from our perspective, we got a demo up and working really, really quickly. We broke a lot of requirements, and it was really ugly, but it worked. We were able to, I think our first thing that we built was the Proto-C compiler on this build system. Had lots of limitations, but we could start getting feedback on it, and we could start actually, even as ourselves, start using it and see what kind of validate all our hypotheses. And finally, recycling. Throwaway prototyping is a common thing, but there's another belief that the first two versions of anything you write, you're probably going to throw away. But I really think that recycling is a much better metaphor than throwing away, because it's not actually waste. And there's a great quote from Frederick Brooks on this. But you're actually, people are learning, you're learning new techniques, you're getting practice, and you're building up skills and capabilities of your team, which is really your biggest asset. And finally, you're paying down tech debt. Again, with anything, if you no longer need it, if it's no longer serving a purpose, get rid of it. Otherwise, it's tech debt, and it's not actually helping you. So in our case, we reused as much as we could, but really we kind of got something working and then replaced all the different pieces once we actually formulated and verified that the APIs were correct and the components actually had that we were building the right thing. We could start replacing them with things which actually met the final requirements. So that's really kind of summed up in our overall development strategy. We hacked together a demo, proving out all the ideas, and then we integrated, nailed down APIs, and figured out how things worked together, and finally replaced everything with real code that was much more maintainable and met all the other requirements. And throughout this entire process, as we're iterating, we could continually get customer feedback. So what are the products? We talked about Bazel and remote build execution a little bit already, but I did mention I was going to come back to this. What is a build tool? So we do get this question in confusion a lot about what we do and what we don't do, but really kind of this table is a great summary. So there's continuous integration, and some examples are listed on the left, but that's just the system that allows you to watch for changes and trigger some tool to actually do your build as a result of those changes. The dev tools are your workhorses. They're just an assortment of tools. There's lots of different things, and they all do kind of like one thing, but a low-level thing. So it might be your compilers or bundlers or other things. And then finally, your build tool is really kind of a generalized solution or even an orchestrator, but all it knows how to do is just run different dev tools. And Bazel is a build tool. It's extensible. It provides a lot of abilities, so you can work with a lot of different dev tools. But the other advantage of this is Bazel is now a single tool that knows how to do things for you. So you don't need to have to use a whole assortment of different tools. You can have one tool that can work with a variety of other systems and make them work well together. So these are some of the properties of Bazel. Bazel is hermetic, and this is because it knows all the inputs. Everything is explicitly defined in Bazel. Additionally, it's incremental. Bazel only builds things that have changed, and it can reduce down to the minimum set. And this is just a result of having explicit declaration of all dependencies and having confidence in that declaration. Bazel can actually look at the action graph and with confidence actually just narrow it down to the smallest set of things that have been touched. And it's deterministic. And that just allows us to have strong confidence in caching intermediate build results, and knowing that if you run the same action again, you're going to get the same outputs means that you don't have to worry about situations where, like make clean, for example. And all of this is kind of wrapped in a tool that's multi-language and multi-platform and can run builds and tests. So a single command can do your entire build tree, no matter what combinations of languages or platforms you're working with. And you get all of this fast, correct, and parallel. Remote build execution is a cloud service. We're currently in alpha, but we're kind of growing with users. And it really kind of leverages a lot of the core constructs of Bazel, but extends it to the next level. So it works with Bazel. So we talked about the CI system. Your CI system will still be triggering and still running your build tool, which is Bazel. But this is a cloud service that kind of augments those capabilities by having a shared cache and shared managed fleets of workers. And all of this allows you to have builds that are faster because you're not constrained by local resources on your local machine. You can scale to the cloud. So you can have pools of workers maybe that don't even match your local machine. Maybe you have GPU requirements of specific types or other things. And Bazel is able to shard the workloads across those remote resources and do it in parallel, which just results in a net performance benefit. Additionally, your resources are shared, and that results in your builds being more efficient. And that's because you're sharing resources now across your entire team. And that's not only your developers, but it's also your CI pipelines are using those same resources, and it means you can use them at scale. And finally, remote builds tend to be more correct. We're leveraging Docker, but you have a much more stronger sandbox. Your sandbox is more comprehensive with remote builds. You can't make any assumptions about a side effect of an action leaving something on a machine because there's no guarantee that the same action is going to run, on the same machine as a precursor action ran. You have to, be able to rely on your dependencies, and there's just a strong correctness guarantee. In RBE, we basically spin up a Docker container that you define, which contains your tool chain. And then we map in all the input files that Bazel knows about for that action so that you can run the action in a complete sandbox, get the outputs, and then tear everything down. And that just gives you a lot more confidence in the overall correctness. I think it's also worth just thinking about the 3 Rs and how they apply to Bazel and RBE. Because Bazel, it reduces the amount of work by only running things that, based on real changes. It can reuse results from previous actions. And recycling, you just run the actions. You can use shared resources, and you can run them much more efficiently. So finally, just a quick skim. We have a lot of internal customers. We've been working with TensorFlow, as I mentioned, was the first one. Angular has been, I know there's a lot of people that have been starting to leverage improvements that have been made for Angular now that they are using Remote Build Execution and Bazel, and a variety of other teams at Google. In addition, we're working with a lot of early external customers, and they've been scaling up workloads. And all of this has resulted in some enormous real-world improvements. So these numbers for TensorFlow were when they first onboarded to us. Since they've actually been unblocked from scaling, what has resulted in developers can actually run more tests and run them more frequently. So the number is actually much, much higher today of how long it would take to run builds without having a scaling solution such as this. And the Angular example is once they turned on CI with RBE, their build times went from an hour down to 7.5 minutes. So we're talking, a real transformation in how you can approach how frequently you build and what you build and test. And it can be really transformational. I'm going to jump into a quick demo. So I've got here a TensorFlow repository that we've checked out. And we have a pool of workers. I think there's so there's workers that we have configured for running this. This is a CPU build. TensorFlow currently is also using GPUs for pools of workers for some of their tests. But right now, we're just going to run some CPU workloads. So you can see we've got a Bazel command, and we're just specifying a remote configuration with some details about the project. And I'm adding a few flags for something called the build event stream, which kind of allows us to collect some metadata associated with individual build actions. And we'll see what kind of value that provides in a second. But Bazel is able to quickly analyze all sorts of targets and run the only things that have changed. And in this case, you can see everything was cached. So it actually went through, I think it's, a whole bunch of tests that were all run, and they were all cached because I just ran a Bazel test command. But what happens if I make a change to a file that maybe all of our tests depend on? So this flags library, or flags file, for example, if I jump down and make a change to this string, GDE summit, and rerun this. And this is going to cause all of our tests to be invalidated and have to run again so that we can leverage the benefits of parallelism at enormous scale. So this is now running through, and it'll take a minute. Part of the problem is that you're still constrained by your longest tests. because Bazel is very good at making very granular actions, and that's one of the benefits of Bazel over a lot of other solutions, is actions are actually very, very tiny for the most part. Tests are an exception to that because you can write, it depends on how you structure your tests. Some of them may actually take a very long time, but you can see we're scrolling through, we've got 500 actions all running in parallel, and we're up to over 1,000 complete at this point. So we're churning through them quite quickly, and this should be done in a minute. And I mentioned briefly about Docker being our approach to containerization. So it's possible to encapsulate your tool chain and whatever versions or anything that you want to depend on in terms of like Clang compiler, things like that, all in a Docker container. And then this gets basically just included in your Bazel configuration. So our system is able to pull that information, and then when an action that requires that container gets run on a worker, we can, most likely that container is cached, and we can stand up an environment and run the action. So we're just down to the last couple of tests that are running.
Thanks.
I just want to jump back to this quickly. So the build is finished. And the one test that actually took a really long time was this test. But let me just make a change here. So this one actually took a while, but we can actually verify that if I jump to this UI. So I mentioned there was a build event stream that was showing a bunch of results. So it was this extract volume patches grad test. Extract. So this one took 3.5 minutes to run, which was definitely kind of a slow test. So if we actually go and maybe let's just take a look and see if we can make this test run a little bit faster. Maybe if we delete a few lines. Now in this case, it's going to rely on almost everything else being cached because we ran all of those tests before. So you can see it's just running the single action that actually has changed. And now that test ran in a couple of seconds as opposed to the several minutes that it ran before. And again, you've got this ability here to actually see all of your targets and anything else that has been run. And you can, if you had errors or other things, you could jump in to see like standard out or logs or other things. All kind of from this unified view of your build. And that just kind of works in conjunction, like Bazel is streaming output and it's being aggregated so that we can dive in and inspect things in greater detail.